Okay, good morning and welcome to this morning's class. At the moment, we don't have too many of you joining the class. I think I have about 69 or 70 participants at the moment, but I would start because we all know that the time is 10 a.m. this morning, and I don't know why they are not here. So, as I've always done, please, if you can hear me, raise your hand up if you can hear me. Okay, so I can see quite a number of hands up. So you can lower it now. You can lower it now. Okay, so I believe there are no more issues with the IA. I haven't had any email since yesterday, and I don't expect to get an email from any of you again because we have given you the chance to retake it. So if you're unable to take it this time around, then there's nothing we can do about it. Um, so yeah, we would at some point release the marks for you, then you know what you got. Some did very well, some got 20 over 20 and all that. Okay, so today we would be continuing with our discussions on consumer behavior. So the last time we met, we looked at the cardinalist approach to consumer behavior. So just to summarize that, so that utility can be measured. In other words, the individual can quantify the satisfaction that he or she gains from consuming a particular good. So if that is the case, then we can look at concepts such as total utility, marginal utility, and then also the average utility. So we define what all these utility concepts are, right? And then we made a key point regarding to the law of diminishing marginal utility. So we define that as the consumer continued to consume more of a particular commodity, the marginal utility diminishes. Or in other words, the extra utility gain from an extra unit diminishes as you continue to consume more of a particular commodity. So that was the law of diminishing marginal utility, right? And um, I tried to make it practical by using a practical example of drinking cups of water, right? And you clearly could see that at some point the extra benefits you gain from drinking an extra cup of water can even become negative, right? So it gets to zero and it can even become negative. So given this, we said the consumer is in equilibrium when the marginal utility of the commodity is equal to the price of the commodity in the case of a single good, right? So we could vary it. I mean, if price should change, then we know the direction in which marginal utility will change. The consumer has no control over price. So to ensure that equilibrium is restored, the consumer has to um, change marginal utility. So if it is an increase in price, then it means that marginal utility is lower than price at equilibrium. So therefore, the consumer has to increase marginal utility. And the only way marginal utility will go up is to consume less of the commodity. If it's a reduction in price, the marginal utility is bigger than price. So marginal utility has to come down. And the only way marginal utility will come down is to increase the consumption of the commodity. So we looked at this, and then we also looked at it more than one good case. So we focus on two commodities, X and Y. So in that sense, the equilibrium situation or condition is that the ratio of marginal utilities should be equal to the ratio of prices, or the marginal utility of one commodity over its price should be equal to the marginal utility of the other commodity over its price. So if the price is in cedis, then that condition means that the marginal utility per cedi of one commodity should be equal to the marginal utility per cedi for the other commodity. And you can use that condition to also derive the demand curve. Right. Today we are going to look at the second approach, which is the ordinal approach, which would achieve the same results as the cardinalist, but will make a different assumption about the quantification of utility. Now, these people believe that utility cannot be measured, unlike the cardinalist approach, where they assume that utility can be measured in utils. But the ordinalist approach believe that utility cannot be measured. Right? In other words, utility cannot be quantified. The level of satisfaction gained from consuming a particular good cannot be quantified. However, the individual can reveal preference for a particular commodity over another. So if the individual is asked to make a choice between, let's say, commodity A and commodity B, and the individual says that I prefer commodity A to commodity B, then it means that A gives him more satisfaction than B. And so the individual can reveal preference over some commodity than another, but the individual cannot say that commodity A gives me 1,000 units of satisfaction and B gives me 900 units of satisfaction, and therefore I am choosing A over B. The individual cannot say that. All the individual can say is that A gives me more satisfaction than B, and therefore I am going for A. But utility cannot be measured. Right? So that's the key difference between this approach and then the cardinalist approach. Utility cannot be measured, but the individual can reveal his preference with regards to what gives him more satisfaction than the other. So this is a key difference between the two approaches. Now, having said this, so how does the individual reaches equilibrium, as in the case of the cardinalist, if we assume that utility cannot be measured, but the individual can review preference for one commodity over the other commodity? How does the individual reaches equilibrium? Now, to explain this, the analysis for the ordinalist approach is divided into two. The first that I will look at has to do with what the consumer can do. What the consumer can do. And the second is what the consumer is willing to do. There are two different things. What you can do and what you are willing to do are two different things. So I'll first of all start with what the consumer can do. Right? What the consumer can do. And that is what I'll start with now. So we know that in consumer behavior, or when we look at how we change our behavior when it comes to consumption of goods and other activities. With reference to commodities, we are constrained, and that constraint is the resource that we have. And in this case, for consumption or buying of goods and services, it's our income. Note that we have defined economics as the efficient way of utilizing our scarce resources to satisfy our unlimited wants and needs. So in consumer behavior, the consumer is constrained, and that constraint is the income that the consumer has. And that will determine what the consumer can do, right? So what I'm willing to do is different from what I can do. What I can do depends on the income that I have or the resources that I have. That will determine what I can do, right? So we are going to look at that, right? What the consumer can do. And to simplify our analysis, we are going to assume that the consumer consumes only two commodities. The consumer consumes only two commodities. And the consumer does not save out of his income, right? So I am going to switch to the whiteboard to explain this in details, to explain what a consumer can do in details, right? In detail. So I want to stop sharing this and then move on to the whiteboard. So you have the whiteboard now. So what a consumer can do. So again, the consumer is constrained by income, right? So given his income, or the income would determine the quantities of the goods that he or she can buy and therefore consume. So we assume that there are only two commodities, commodity X and then commodity Y. These are the only two commodities. The price of commodity X is PX, and the price of commodity Y is PY. Let's use I to represent the income of the consumer. So I is representing the income of the consumer. And then again, we assume that this consumer does not save. So the consumer spends all his income on the two commodities. This consumer does not save. So if that is the case, then the consumer's income should be equal to his expenditure. If that is the case. So you do not save, so your income should be equal to your expenditure. Now the expenditure of the consumer will comprise of expenditure on commodity X plus the expenditure on commodity Y. So your income should be equal to the expenditure on commodity X plus the expenditure on commodity Y. Expenditure on commodity X is equal to the price of X times the quantity of X that you purchase. And then the expenditure on commodity Y will be equal to the price of Y times the quantity of Y that you purchase. So your income should be equal to that. Now this equation here is what we call the budget equation of the consumer. That's the budget equation of the consumer. And this shows what a consumer can do. given his or her income, and also the prices of the commodities that he or she consumes. Right? So that's what you see as a, so the budget equation is an equation that shows the relationship between income and then the quantities that the consumer can purchase in the market. Now we can draw the graph of this budget equation, and that graph or line is what is known as the budget line. So let's quickly look at how to draw the budget equation or the graph of the budget equation. So I have the equation. So I have the equation as, so I'm coming. I don't know what's happening here. I'm coming, let me do it again. Okay, so the equation is income is equal to the price of X times the quantity of X plus the price of Y times the quantity of Y. So I want to draw the line or the graph of this equation. Now, from our secondary school mathematics, we know that this equation is a linear equation. So this is a linear equation. So it's a linear equation. And we know that to draw the line or the graph of a linear equation, you need 2 points to do that. You need 2 points to draw the line or the graph of a linear equation. So the commodities are X and Y. So we need our X and Y quadrant. So I have X on the horizontal axis and then Y on the vertical axis. Right? So I have X on the horizontal axis and then Y on the vertical axis. Sorry, let me get the equations again. So the price of X times the quantity of X plus the price of Y times the quantity of Y. So it's a linear equation, and therefore we need only 2 points. So I have X on the horizontal axis and then Y on the vertical axis. Okay. So to draw this, I only need 2 points. I need 1 point on the Y axis and then another point on the X axis. And if I get these 2 points, I'll just trace a line to pass these 2 points, and that will give me the graph of the linear equation. So to find the point on the y-axis, just assume that if X is 0, so if the consumer does not spend anything on commodity X, but spend all his income on commodity Y, what will be the quantity of Y that the consumer will purchase? So Y will be equal to the income of the consumer divided by the price of Y. So this is 1 point here, which is the income of the consumer divided by the price of Y. So that gives us 1 point here. The second point, you turn it. If Y is 0, what will be the quantity of X consumed? The consumer is going to consume the income divided by the price of X. So I have another point there as the income divided by the price of X. So having these 2 points, I can join them now. And this line is what we call the budget line. This line is what we call the budget line. So the budget line here shows the combinations of X and Y that the consumer can purchase. Right? So it shows a combination of X and Y that the consumer can purchase with his given income. So now every point on the budget line is a combination. Every point on the budget line is a combination that the consumer can purchase given the level of income. Okay, so let's take a practical example. Let's take practical example where we use figures to generate the budget line. So let's say the consumer has an income of 200 and the price of commodity X is 4 plus the price of commodity Y is 5. So this is the budget equation. And you are asked to draw the line of this equation. So all you do is you have your Y and X quadrant. So X is here. So you start. If X is 0, Y should be equal to 40. So if the consumer does not consume any of X, then it is going to consume 40 units of Y. The same way, if Y is 0, right? If Y is 0, then X is going to be 50. So you locate 50 here. So what do? You now join the line, the two, and this is the budget equation. So every combination here on this line completely exhausts the income of the consumer, right? So this is what the consumer can do, right? That is what the consumer can do. Every point on it completely exhausts the income of the consumer. Okay, so please, that's the budget line and how you can derive it. Now there are some few other things that I want us to discuss with regards to the budget line. And the first one is the slope of the budget line. It's important because we will need that at some point when it comes to the equilibrium of the consumer. So the slope of the budget line. So the slope of the budget line. So given that we have commodity Y on the y-axis and then X on the x-axis, or Y on the vertical axis and then X on the horizontal axis, the slope of the budget line will be equal to change in Y over change in X. That will be the slope of the budget line. So change in Y over change in X. So from what we have here, assuming this is point A and then this is point B. So let's see, we are moving from point A to point B. let's calculate the change in y and also the change in x. So moving from point A to point B, the change in y is minus 40 because y was 40, x was 0 at point A. So if we move to point B, y becomes 0 and then x is 50. So there's a reduction in y. So that is why it is negative 40. And then the change in x is from 0 to 50. So that is an increase. And then we have it as 50. So if you cancel this, it means that the slope of this budget line is minus 4 over 50. Now, what do we see? We see that this 4 here is the price of x, and then 5 is the price of y. So therefore, we can say that the slope of the budget line is minus px over py. In other words, the slope of the budget line is the relative price ratio. The slope of the budget line is a relative price ratio. I can see some hands up. Let me go and check what is it, and then I'll come back. So the relative price ratios, I saw 2 hands up. Okay, so let me get to them. Eric.
Yes, sir. Sir, please, I wanted to know why the when we are doing the changing, why it changed to negative.
Why is what? Can you increase your voice? I can't hear you.
Yeah, I want to know why the 40 changed to negative when we're doing the change in y.
So I think I've explained that here. I told you that moving from point A to point B, at point A, y is 40 and x is 0. At point B, y is 0 and then x is 50. So it means that there's a reduction in x. Sorry, there's a reduction in y from 40 to 0. So there's a decrease in y. That is how come y is minus 40. And then also for x, there's an increase. Initially it was 0, but it increases to 50. That's how come it's positive, right? I mean, note that the budget line is downward sloping, and any for any downward sloping line, the slope is always negative. Just like the demand curve, the slope is always negative. So that is how, this is what explains the negative minus 40. Initially it was 40, but it's gone to 50. So there's a reduction. That is why we call it, that's why it's minus. Or you can say that the slope is y2 minus y1. You can do this way. That will give you the change in y. And then x2 minus x1. So if you like, do it this way. So now at A, that is where we have the ones. And then we move to B, right? So B is the 2. So at A, 1, y1 is 40. And then at B, y1 is 0. So it will be 0 minus 40. That gives you the change. And then this will also be 50 minus 0. So 0 minus 40 is minus 40. That's why you have that over 50. So Eric, I hope it's okay now. I saw another hand up, but they have lowered them. So there's Agnes. Okay, so Agnes, go ahead.
Yes, my question has been answered.
Okay, all right. Any other?
Thank you.
Okay, so once all questions have been answered, now we can move on. So please take note. of the slope. So you see that the slope of the budget line here is the relative price ratios, right? You see it as a relative price ratio, the negative of the relative price ratios, right? Now, I want you to take note of something here. We are having the slope of the budget line as minus px over py because of where we place y and x in the quadrant. So we place y on the vertical axis and then x on the horizontal axis. If it had been the reverse, where we have y on the horizontal axis and then x on the vertical axis, then the slope of this line will rather be minus py over px. So please take note of this. It's very important, which is still the relative price ratios, right? So the relative price ratio, the rate at which the consumer can substitute one commodity for the other. So the slope here is measuring the rate at which the consumer can substitute one commodity for the other. So if you have it that this way, so it means that to gain an extra unit of y, the consumer has to give up this unit of x to gain an extra unit of y. All right? The same way here, to gain an extra unit of x, the consumer has to give up this unit of y to get an extra unit of x. So please take note of these differences and don't be too rigid in learning. So the slope, we have minus px over py because y is on the vertical axis and then x is on the horizontal axis. It could change, right? Y could have been on the vertical axis and x could have been on the y could have been on the horizontal axis and x could have been on the vertical axis, and therefore the slope will rather be the reverse, as you see here. Okay, good. Now, given that we know what a slope is now let's look at what would cause a change in the budget line. Things that will cause a change in the budget line. So I'll look at changes in the budget line. Now there are two things. So changes in BL. There are two things that will cause a change in BL. So one is change in price. So the change in price of commodities or the commodities. And then the second one is a change in income of the consumer. Change in income of the consumer. So let's first of all start with the change in price. Right, let's first of all start with the change in price. So I am going to use the same budget equation that I used earlier. So 200 is equal to 4x plus 5y. So this is our budget equation. And then let's draw our initial budget line. So we have commodity X on the vertical, on the horizontal axis, and then we have commodity Y on the vertical axis. So we got 40 here. So let me just draw it. So we had 50 here, and then we had 40 here. Right? Okay. So now let's assume that the price of X doubles, holding the price of Y constant. So the price of X increases by 100%. So it doubles. holding the price of Y constant. So in that sense, we would have 200 would be equal to price of X double. So we have 8X plus 5Y. So let's draw the budget line for this new budget equation. So you see that for Y, we will continue to have our 40 on the vertical axis. Now let's see what Y will be. Sorry, X would be. So X will now be 8 divided by 200, and that should give you 25. So you see what has happened to the budget line with the price of X doubling. You see that it has rotated inward along the commodities whose price is changing. It has rotated inward. Another thing is if price of X rather reduces by 100%. If price of X reduces by 100%, then the new budget line or budget equation would be 200 is equal to, so by 100% will be 2X plus the same 5Y. So you see that Y will still remain 40, but now X is going to increase to, let's say 100, not even let's say, but to go to 100. So what do we see? We see that the budget line rotates outward along the axis of the commodity whose price has reduced or gone down. Right? So this is what will happen to the budget line when the price of commodity X change. It can go outward when it is a reduction in the price of commodity X, and it will go inward when it's an increase in the price of commodity X. Now you can do the same for commodity Y. You vary the price of commodity Y, holding the price of X constant. Right? So you can have X here. And then we have our initial budget line where we had 50 for X, and then we had 40 for X, for Y. So now again, let's do the same. We double the price of Y so that the new budget line becomes 200 is equal to 4X plus 10Y. So you double the price of Y. In that sense, the X will remain the same, 50, but the Y will now reduce to 20. So if you draw the straight line, that gives you again the budget line, the new budget line. So what do you see? It has rotated inward along the vertical axis. And you can vary it by reducing the price of Y. So in that sense, let's say we have 200 is equal to 4X plus, let me reduce it, let me say 2Y. So in that sense, you see that it's going to rotate outward. And this will be 100, right? So that is how a change in price of one commodity holding the other commodity, the price of the other commodity constant, affect the budget line. Now you can do an experiment where you change the price of both commodities at the same time, right? Or you can do an experiment where one increase, one decrease. You should be able to draw the new budget line, and you clearly see what will happen to the budget line with the new equation. Okay, so that I leave that for you. as your practice question. When you get to your respective hostels, you can do that on your own. But let's look at what happens when there's an income change. So what happens when there is an income change? So again, the budget equation is 200 is equal to 4x plus 5y. So that's the budget equation. So now, and we draw this budget, the line of this budget equation. So I have 50 here for x, and then I have 40 for y. Right. So now let's assume that income of the consumer doubles. The income of the consumer doubles, so that instead of 200, we have 400. So income doubles, price of commodity remains the same. So plus 5y. So let's draw the budget line for this new equation. You see that y will also double, so we have 80 here, and then this will also double. We can have 100 here, or we'll have 100 there, and then you draw the straight line. So what do we see? We see a parallel shift. This is not a rotation, but a parallel shift of the budget line to the right as a result of an increase in income, right? And if it's a decrease in income, it will be a parallel shift to the left. So it will come down to the left when income decreases, but prices of the commodity remain the same, right? So you see what would happen to the budget line with an increase in income and then a reduction in income. So with income changing, with prices remaining the same, the budget line would shift parallelly, either to the right or to the left, right? Okay. Now let's do this exercise to see, to gauge your understanding of what we have done so far. So assuming that both income and prices increases by 100%. How would that affect the budget line? What is the effect of this on the budget line? Right? So draw it. Take your exercise book. Maintain. Okay, so let me get it. So we have our 200 as budget line. So we have 4x plus 5y. So when we draw our initial budget line, so y is on the vertical axis, x is on the horizontal axis. So we had 40 for y, and then we had 50 for x. So now income goes up by 100%. And at the same time, price of x and price of y also goes up by 100%. Show the effect on the budget line. So do it. If you are ready to answer, you raise your hand up and then I'll call you. So do it. If you're ready to answer it, you raise your hand up and then I'll call you. So tell me the effect of this on the budget line. Hey, what is happening? Nobody has been able to answer it. I can't see any hand up. So I'd rather see messages in the chat dialogue. Okay, so I can see some hands up. And Deborah, go ahead.
Sir, please, it won't change. It will remain the same.
Okay, so Deborah says that the budget line will remain the same. It will not change. Do you all agree? Let me see. Michael, do you agree?
Yes, sir.
You agree that it will remain the same?
Yes, please.
Okay, so Michael agrees. Forcing Alfred, do you agree?
Yes, sir.
Forcing Alfred, do you agree that it will not change, it will remain the same?
Yes, sir. It will not change.
Okay. So yes, it's true. The budget line will not change. It will remain the same. So you see, we would have some people who would think that when this thing happens to them, something has changed in their life. So this is what. So this is just saying that even if you receive 100% pay increase, and the items that you spend your money on also experience 100% increase in prices, nothing has changed in your life. You should go back and ask for more pay increase, right? So now what we see that labor at the moment is agitating for pay increases because prices of items have all gone up. Fuel has gone up, everything is going up. Yet salaries have not changed. So you see that now we are coming out agitating for pay rise and all that. It's to actually minimize the impact of these price increases. So if someone experience this and act as if he has seen a pay or something has changed in his life, that person is said to be suffering from money illusion. Right? He's suffering from money illusion. Right? You have had 100% increment in salary or income, and at the same time, prices of items have gone up by 100%. Nothing has changed in your life. If you act as if you have more income now, you'll be suffering from money illusion. Right? If you act as if something has changed in your life, then you'll be suffering from money illusion. Johnson, I don't know what you want me to do. So the explanation has been provided. The budget line will not change. The budget line will remain the same because income have gone up by 100%, prices too have gone up by 100%. And therefore nothing has changed in your life. You are still where you are, right? Okay. So any question on the budget line or on what the consumer can do before I move on to what the consumer is willing to do? So I still see 2 hands up. I have Forcing, your hand is still up. So if it's to ask a question, you can, but if
No,
not,
sir.
you can lower it.
No.
Forcing, we can't hear you.
No, sir. No, sir, it was a mistake.
Okay, then there's another person with a hand up, Samuel.
Good man.
Samuel,
Same mistake, sorry.
okay, all right. So I've lowered that as well. Okay, so any question on what the consumer can do so far? If there's no any question, then let's move on to what the consumer is willing to do. Right, what the consumer is willing to do. So I'll go back to my slides. I want to stop sharing the whiteboard and then go back to the slides. So I have discussed extensively everything about the budget line. But there's one quick thing I want to discuss with you. Let me go back on the budget line, and that has to do with the slope. So mathematically, there's a way for deriving the slope of the budget line. So I have I equal to px times x plus py times y, right? And when we draw the line, we have x on the horizontal axis and then y on the vertical axis. So here it's assumed that y is the dependent variable and then x is the independent variable. So mathematically, the equation of this line should rather be y being the dependent variable and then the x will be the independent. So you just have to make y the subject in this equation. If you do, then y will be equal to I over the price of y minus px times x over the price of y. So this is how you represent the equation of this line, having y on the vertical axis and then x on the horizontal axis, right? So if this were to be the equation, then mathematically we can use what we call the concept of differentiation or derivatives to derive the equation, or sorry, the slope of this line. So in terms of derivative, we have dy x. This is for those who know, who have done some maths. Dy x, which is the same as change in y over change in x. And that would be equal to, using the rules of differentiation, the price of x over the price of y. So I am not going to go through the rules of differentiation with you. I believe it's something you do in the second semester when you are doing the maths. So I'm not going to go through that with you. But just to let you know that mathematically, the slope of the budget line can be obtained as the derivative of y with respect to x, which is the same as y die x, sorry, which is the same as change in y over change in x, and that is equal to minus px over py. Don't come and ask questions on this. If you don't know differentiation, I cannot help you on that. But let me see those who have raised your, I can see a hand up. So, okay, the hand has gone down. But I see some messages in the chat dialogue. Let me check what it says. Okay, so it's not anything that is worthy of. It's not anything that is worthy of. Well, somebody saying, can we say the slope is the coefficient of x? Yeah, in differentiation, when you differentiate the y with respect to x, you get, so you get minus px over py. So this, another way of writing this is to say I over py minus px over py all by x. So if you are done differentiation, you will see, of course, it will be, the reason why it is equal to the coefficient of x is to the power 1. So when you do that differentiation, you'll get it that way. Okay, so please, that is a way of maths. For those who have done some elective maths, they would understand this, but those who haven't, it will look like Greek to them. Sorry. Okay, so now let's move on to what the consumer is willing to do. Okay, so what the consumer is willing to do now. So I've discussed extensively what the consumer can do, all these things. So this is what I was talking about. The maths bit is what you see down there. So let's go on to, I've also discussed the changes in the budget line with you. And now we are going to look at what the consumer is willing to do. Okay, so in the ordinalist approach, what a consumer is willing to do is represented by an indifference curve, right? So what a consumer is willing to do is represented by an indifference curve. And what is an indifference curve? It is a combination of commodities or goods that yield the same level of satisfaction to the consumer, right? So when we say it gives you the same level of satisfaction, it means that you are indifferent between those combinations, right? So let me switch back to my whiteboard to explain this further. So we are saying that combinations of commodity bundles that yield the same level of satisfaction to the consumer. So again, the commodities that we are looking at are commodity Y and then commodity X. So commodity Y and commodity X. Now, of course, the consumer can consume different quantities of X. So we can have, let's say, a bundle that has 10 of Y and then let's say 5 of X. We can have another bundle that has 7 of Y and let's say 8 of X. We can have another bundle that has, let's say, 5 of Y and then let's say 15 of X. Now, if the consumer says that A, B, and C gives him the same level of satisfaction. So whether if he consumes A, he gets the same satisfaction as consuming B, and then if he consumes C too, he gets the same satisfaction as consuming either A or B. then the consumer is said to be indifferent between A, B, and C. So you are indifferent. So A and B, you are indifferent between them. The same thing, you are indifferent between B and C. So A, B, and C gives you the same level of satisfaction. Now, if we plot this point on X and Y quadrant, again, we have Y here, and then we have X here. And we try to plot these points, point A, point B. They will all be on the same, curve. That curve is what we call an indifference curve. So on this curve, we have point A, we have point B, and then we have point C. So all these points will offer the same level of satisfaction to the consumer. And that curve is what we call an indifference curve. So the name stems from the fact that the consumer is indifferent between A and B, and also indifferent between B and C. So hence the name, an indifference curve, right? So an indifference curve again so some will say is the locus of the combinations of commodity bundles that yield the same level of satisfaction to the consumer. So every combination on this point will yield the same level of satisfaction to the consumer. So that's what an indifference curve is. Okay. Now, indifference curve have certain properties. Indifference curve have certain properties. So let's look at what these properties are. Let's look at what these properties are. One is that indifference curves are convex towards the origin. Although we have special cases of indifference curves, which we are not going to go through at this point. So I want to look at properties of indifference curves. The properties of indifference curves. So one, they are convex towards the origin. So they bow, it's a bow shape. So it bows inward. So this is what I mean. It bows inward like that. So that makes it convex towards the origin. And then they also slope downward from left to right. So it slopes downward right from left to right. So that's another property. 3, the farther it is from the origin, the more satisfaction the consumer gains. So what we are saying is that if you have these two indifference curves, so indifference curve 1 and then indifference curve 2, the 1 or the 2 offer more satisfaction to the consumer than the 1. So any point on 2 will give the consumer more satisfaction than 1. 4, another property, indifference curve are everywhere dense. So they are everywhere dense. And what it means is that every point in the commodity space has an indifference curve passing through it. So every point in this space will have an indifference curve. There are so many indifference curves in this commodity space. So that's why we are saying they are everywhere dense. Indifference curves are everywhere dense. Every point in the commodity space has an indifference curve passing through it. There's another characteristic, which is two indifference curves do not intersect. We can talk about that. So two indifference curves do not intersect. They do not intersect. And let's explain why two indifference curves should not intersect. Right? Let's explain why two indifference curves should not intersect. Now, in consumer behavior, particularly with what the consumer can do, preferences has to be consistent for us to be able to study the behavior of the consumer. And there are some assumptions of preferences or axioms of preferences that are made. Somebody is asking whether no, not necessarily. I mean, you don't need to draw them to scale. So in studying consumer behaviors, there are some axioms that has to we need to ensure that these exist for preferences to be consistent. And one of the axiom is the axiom of transitivity. So we have the axiom of transitivity. CTVT. The axiom of transitivity. And what does that axiom says? Let's look at it. It's saying that if you are faced with three options or bundles, and these are A, B, and C, and you are asked to choose between A and B, and you say that you prefer A to B, right? So if you are faced with a choice between A, B, and C, and you're asked to choose between A and B, and you say, oh, I prefer A to B, and then you're also given a choice between B and C, and you say, oh, I prefer B to C. Then for consistency, for your preferences to be consistent, then if you are asked to you are faced with a choice between A and C, you should always prefer A to C, right? Do you get it, please? So I'm asked to choose A. I have three options, A, B, and C. And I'm faced with a choice between A and B, and I said I wanted A. Right? So it means that for me, A is better than B. And I'm faced, if I don't have A, and I'm faced with a choice between B and C, and I choose B. So for me, B will be better than C. Then if you ask me to choose between A and C, I should never choose C over A. If I choose C over A, it means that I'm not being consistent with my preferences. right? I'm not being consistent with my preferences. So the axiom of transitivity, this is what it says. If you have A and B and you went for A, okay, and you have B and C and you went for B, then you should never go for C when you have A and C. Because you have shown that C is, I mean, you went B, you B between, you have A and B, you went for A, because you prefer A to B. And then you have B and C. You said, okay, I want B. So B is better than the C for you, and even A is better than B for you. Then if you are faced with a choice between A and C, there's no way you should choose C over A. The same way, if you say you are indifferent between A and B, so if you ask, oh, whether I get A or I get B, I am okay. They will all give me the same level of satisfaction. And you also say that you are indifferent between B and C, right? Then if you are faced with a choice between A and C, you should also say you are indifferent between A and C. So they will all give you the same level of satisfaction, right? Okay. Now this axiom is violated when two indifference curves intersect. And we are going to explain that. So this axiom is violated when two indifference curves intersect. So let's explain that. So I'll clear this and let me draw two indifference curves intersecting each other. So I have commodity Y here, I have commodity X here. Then this is one indifference curve and this is another indifference curve. Now let's get the points. So let's say this is point A, and let me assume that this is point B, and let me say this is point C. So now let's get it. So it means that if you look at the indifference curves, since indifference curve 2 is on a higher level, it means that the satisfaction from indifference curve 2 is higher than the satisfaction from indifference curve 1. But now let's see. Note that all commodities bundle on the same indifference curve offer the same level of satisfaction to the consumer. They offer the same level of satisfaction to the consumer. And therefore, the consumer should be indifferent between A and B, because A and B is on the same indifference curve, right? So you should be indifferent between them. The same way, the consumer should be indifferent between A and C, because A and C are also on the same indifference curve. And therefore, by the axiom of transitivity, the consumer should be indifferent between B and C. However, that is not the case, because the utility from B is higher than the utility from C, because B is on a higher indifference curve than C. And therefore, the assumption is violated. So that is why we are saying that indifference curves do not intersect each other. If they do, then we will be violating the axiom of transitivity, or the assumption of transitivity, which I have clearly explained to you. Right? Good. So I think that is all the properties of the indifference curve that I want to talk about. Now, let's look at the slope of the indifference curve. So just as we looked at the slope of the budget line, we want to look at the slope of the indifference curve. So let me draw an indifference curve with X on the horizontal axis and then y on the vertical axis. So I have this indifference curve. So this is indifference curve UO. Now, one thing you should know about the slope of an indifference curve is that the slope is not constant. So you see the indifference curve is not a straight line. So it does not have a constant slope as the budget line. It does not have a constant slope as the budget line. So again, what will be the slope at every point? So it will be change in y over change in x as a slope of the indifference curve. Right? Now, I'm not going to go too much into the mathematics at this point, but we will do some math examples in our next meeting. But we can show that the slope of the indifference curve at every point is the ratio of marginal utility of x over the marginal utility of y, the negative. So we can show that the slope of the indifference curve at every point on the indifference curve is the negative of the ratio of marginal utility of x divided by the margin. So it's the negative of the ratio of marginal utility of x and the marginal utility of y. So it is the negative of marginal utility of x divided by the marginal utility of y. Now again, let me warn you here. The reason why we are getting MUX over MUY is because we have x on the horizontal axis and then y on the vertical axis. Right? Because we have x on the horizontal axis and then y on the vertical axis. If we had y on the vertical axis, y on the horizontal axis and then x on the vertical axis, then the slope would have been changed in x over change in y, and that would have been equal to marginal utility of y over the marginal utility of x. That is the negative of that. Right? So please take note of this. Right? The reason why we have it as MUX over MUY is because of where we place y and x. But throughout the notes or the slides, x is always on the horizontal axis and y is on the vertical axis. So please, but take note that it can change if we reverse where x is and where y is. So somebody is asking whether the negative affect the MU. No, the negative affect the whole ratio. Mathematics, if I say minus 5 over 2, it affect the whole answer is negative, right? So it is affecting, it is the whole thing that is negative. So the whole answer is negative. Even if you make the negative affect only MUX, and that you still get the same answer. The answer is going to be negative, right? So this is some basic mathematics for you from your secondary school. Okay. So please take note of the slope. Now, like I said, there's a mathematical way of deriving this, but at this point, I don't want to introduce it. But note that the slope of the indifference curve, given that we have x on the horizontal axis and y on the vertical axis is equal to the marginal utility of x over marginal utility of y, and so forth. Okay, so that is how you get the slope. And note that it's negative because the indifference curve slopes downwards. All right. Okay. Now let's move on. Now there's another concept that I want to introduce apart from knowing what the slope of the indifference curve, and that is what we call the marginal rate of substitution. So the marginal rate of substitution, MRS. And what is it? Now, you see that as you move along an indifference curve, there's a trade-off. So you see y here, and then you see x here. And if this is our indifference curve, so let's say we have point A here, and then we have point B here. So what do you see? You see that as I move along the indifference curve, there's a trade-off. I am substituting one commodity for the other. So if I move from point A to point B, I gain more of x, and then I reduce y. Okay. Now, the rate at which the consumer substitute one commodity for the other is what we call the marginal rate of substitution. Right? So how many units of y should I give up to get a unit of x? That is the marginal rate of substitution. The rate at which the consumer substitute one commodity for the other is the marginal rate of substitution. Right. Now we can show that the marginal rate of substitution, which we call the MRXY in this case, is equal to the negative of the slope of the indifference curve. So the slope of the indifference curve is already negative. So MUX over MUY. So the marginal rate of substitution, which has to be positive, right, is a negative of the slope of the indifference curve. Note that the slope of the indifference curve is already negative. So negative will become positives. And therefore, the marginal rate of substitution of x for y is equal to the marginal utility of x divided by the marginal utility of y. So please take note of this. There is a whole mathematical derivation for this, but like I said, I'm not introducing it at this point. Right? I'm not introducing it at this point. So you know what marginal rate of substitution is and how you can get it, right? It being the negative of the slope of the indifference curve. And the slope of the indifference curve is already negative. So negative will give you a positive figure. Now there's this law, which we call the law of diminishing marginal rate of substitution. The law of diminishing marginal rate of substitution. And what does the law say? It says that as you continue to substitute one commodity for the other, the rate at which you substitute it declines. So here, if the substitution rate is 2 or 4, when you go on, it will go to 3, it will go to 2, it will go to 1, and so forth. So as you move along the indifference curve, the rate at which you substitute one commodity for the other diminishes. And that is what we call the law of diminishing marginal rate of substitution. So please take note of that as well. The law of diminishing marginal rate of substitution. So the law says that as you continue to substitute one commodity for the other, the rate at which you do that substitution declines or diminishes, right? So as you move along the indifference curve, the rate at which you substitute one commodity for the other declines or diminishes. And that is what is known as the law of diminishing marginal rate of substitution. Good. So now we are now good to consider the equilibrium now. So now we have looked at what the consumer can do and what the consumer is willing to do. So by the ordinalist approach, the consumer is in equilibrium when what he can do is equal to what he's willing to do. So the ordinalist approach, the consumer is in equilibrium when what he can do is equal to what he is willing to do. So what he can do is represented by the indifference curve, sorry, the budget line. So we have Y here, and then we have X here. So we have X here. Yeah. So what he can do is represented by the indifference, the budget line. And what he's willing to do is represented by the indifference curve. So at what point would they be equal? They will only be equal when the budget line or the indifference curve is tangent to a budget line. When the indifference curve is tangent to a budget line, that point is the equilibrium point. So when an indifference curve is tangent to a budget line, then the consumer is said to have reached equilibrium. Now, at that point, the slope of the BL is equal to the slope of the IC at that point. So it means that the slope of the IC, which we showed as negative MUX over MUY. And then also the slope of the budget line, we showed it as what? Minus PX over PY. So these minus can cancel each other here. So at the end of the day, we have MUX over MUY is equal to PX over PY. Now this is the equilibrium of the consumer using the ordinalist approach. Now what do you see? You see that it's the same as the equilibrium of the consumer for the cardinalist approach when you have two commodities, right? When you have two commodities. So this is where we say the consumer is in equilibrium. So the consumer is in equilibrium when what he can do is equal to what he's willing to do. So at this equilibrium point, he's going to consume this unit of X and then this unit of Y. This unit of X and that unit of Y. Okay? Now, in our next meeting, we will derive these bundles, or we will derive X, the quantity for X, and the quantity of Y mathematically in our next meeting. I'm not going to introduce that today, but it will be done in our next meeting, where we will specify a utility function and then also have a budget constraint. And then we work out for the quantities of X and Y that maximize the consumer utility. So at the equilibrium point, utility is maximized. So please take note of that too. At the equilibrium point, utility is maximized at the equilibrium point. Take note of that as well. Okay. So before we come to the mathematics next week, let's look at two other concepts regarding this equilibrium. And these are the price consumption curve and also the income consumption curve. Right? So, but please take note of this equilibrium point. We will use it when it comes to the calculations for the optimal bundles for X and then Y. So let's quickly look at the price consumption curve, which we call the PCC, and also the income consumption curve, which we call the ICC. So now the price consumption curve is just a line that traces new equilibrium points when price of one of the commodity changes, right? So it is just tracing, it just join. Let me say it is joining equilibrium points, new equilibrium points when the price of one of the commodity changes. And then the income consumption point or consumption curve is also a curve that joins new equilibrium points when income of the consumer changes. Right? So that's what these two curves are: price consumption curve and then income consumption curve. So price consumption curve joins new equilibrium points when price of one of the commodity changes. And then of course, income consumption curve is joining the new equilibrium point when income of the consumer changes. So let's start with the price consumption curve by drawing an equilibrium point, an initial equilibrium for the consumption of commodity Y and then X. So let me get an initial equilibrium point. So let me assume that this is the equilibrium point. So this is our indifference curve 1. Right? Now, how the price consumption curve for X. So now the commodity in question is commodity X. So it is commodity X that we want to change its price, and then use that to trace new equilibrium points, which will give us the price consumption curve. Now, how the price consumption curve would look like depends on the relationship between commodity X and then commodity Y. And of course, from our discussions of demand, we know that two commodities can either be substitutes or complement. Or yes, we can have even a situation where there is no relationship between the two commodities at all. But let's just say they are either substitute or complement. Now, what did we say substitutes are? Goods that you can use in place of each other. So it means that when the price of one go up, the demand for the other should go up. And when the price of one comes down, the demand for the other should come down. So here we are assuming that the price of commodity X is coming down. So the price of X comes down. So if the price of X comes down, from our earlier discussions on what changes the budget line, we know that the budget line is going to rotate outward that way. So now this is going to be tangent to a new, is going to be tangent to a new indifference curve. Now we have to draw it in such a way that the new point or the new equilibrium will show that commodity X has increased, but commodity Y has decreased because X and Y are substitute. And the price of X has fallen. So more of X will be purchased, and then Y, less of Y will also be purchased. So I have another point here. So this point here is indicating, showing that commodity X, the consumption of X has increased, but the consumption of Y has come down. Initially, we were consuming this quantity of Y. Now we are consuming this quantity of Y. And then initially we were consuming this quantity of X. And now we are consuming this quantity of X. So you see that X has gone up, but quantity of Y has come down. So assuming this is the only 2 points, I can draw a straight line to pass the 2 equilibrium points. And that straight line is what we call the price consumption curve for X when X and Y are substitutes. So you see that it is what? Negatively sloped. So the price consumption curve for 2 commodities that are substitutes slopes downwards when they are substitutes. So price consumption curve for 2 commodities that are substitutes slopes downwards, right? Now let's get the price consumption curve when they are complement. So the price consumption curve when 2 commodities are complement. So this is X, and again, this is Y. Let's get our budget line and get our initial equilibrium. So here, at this point, this quantity of X is consumed, and this quantity of Y is also consumed, right? So this is our indifference curve. So now X and Y are complements. And of course, we know what we mean by complementary goods. So they are used together. So the price of X falls. It means that the budget line will rotate outward on the X-axis. So now we have to draw the new equilibrium to show that both consumption of Y and X has increased because they are complement. If the price of X falls, more of X will be consumed. And since X and Y are complement, more of Y will also be consumed. So we have to draw it in such a way that they show the new equilibrium, which is the new indifference curve, will show that both the consumption of X and then the consumption of Y has gone up. So if I draw a straight line to pass these 2 points, that is the price consumption curve for X when X and Y are complement. Right, so please take note of that as well. the price consumption curve for X when X and Y are complement. Okay, now let's get the last one, which is the income consumption curve, which is the ICC. So let's draw our initial equilibrium. So we have X here and then we have Y. So we draw our initial budget line and then we draw our new or our initial equilibrium where the consumer consumes this unit of X and then consume that unit of Y. Right? So this is our indifference curve. So we want to look at the income consumption curve for commodity X again. Now, if it also depends on whether commodity X is an inferior good or a normal good. So we know what a normal good is. A good that you buy more when your income increases. Right? And then we also know what an inferior good is. A good that you buy more when you buy less when your income increases. So let's say that the income of the consumer go up, so that the budget line is going to shift parallel. So this is a new budget line. Now, if X is a normal good, then I have to draw the new equilibrium point such that X would have increased compared to this. So we can, if both X and Y are normal goods, if both X and Y are normal goods, then I have to draw it in such a way that the new equilibrium point will show an increase in both. So I have my U1. So this is the new equilibrium point, which shows that X has increased and then Y2 has increased because both are normal goods. You can draw a straight line to pass through it, and that will give you the income consumption curve for X and then Y when both are normal goods. Right? Now you can vary it. Let's say when X is an inferior and Y is a normal good. When X is an inferior and Y is a normal good. So when X is an inferior and Y is a normal good, let's see what can be done. So we have Y on the vertical axis, X here. So let's get our initial equilibrium. So let me put that down here because I have to. Okay. So we consume this unit of Y, and then you consume this unit of X. So now income increases. You have your new budget line, but X is an inferior good because then it means that he has to consume less of X. But Y is a normal good. So the new indifference curve should be tangent here. So if I draw a straight line, I will have it as that. So that will be downward sloping income consumption curve. Right? That will be down sloping income consumption curve. So you can vary it. You can decide also to look at the case where Y is an inferior, and then X is a normal good. And then draw the income consumption curve for such a situation. Okay. Now somebody asked a question. Roger, you say I should do what? I should go over the PCC again. No. You can. I will make available the recordings to you immediately, so you can play it back, and then just watch how I did it. I think that will give you further explanation. I don't think I want to go back to do all that again. So I have a hand up. Let me just check that person, and then we will end today's class. So I have Michael. Yeah, Michael, go ahead.
Sir, please, I don't understand anything. Wow.
You don't understand what?
Yeah, the whole drawings and stuff.
Well, the good thing is that the recordings will be made available. So take your time, listen to the recording, just watch what I was doing. If you pay attention, you will understand it. Right, Michael? So I'll make the recordings available to you immediately. If you watch the video, the recordings, and you follow me closely and you don't do any other thing, you would get it. Okay, so let me see some other. Okay. All right, so there's no any question that is worthy of responding to. All right, so I think we'll bring the end of, I'll bring this class to an end. So our next meeting, is it Friday? I think. I'm not sure, but in our next meeting, we are going to look at how a change in price will affect the optimal bundles. So in other words, we want to look at the total effect of a price change. And that can be distinguished into or divided into substitution and then income effect. So that will be what we'll be discussing in our next meeting. And in addition to that, we will take a practical example in terms of calculating for the optimal bundles for commodity X and Y. If you don't pay attention, you will never understand this. So if you are listening or watching and you are doing some other things there, you will not understand. And you won't come back to come and tell me that you don't understand anything and I have to do all over. No, we will not do that. If you pay attention, you will understand this. Follow what I'm doing closely. This is just graph. This is basic graphs that you know. So if you do not understand, it means you are not paying attention to me. So you have a second opportunity to look at the video, sit down, pay attention attentively to the video, and then you will understand it. Okay, so that brings us to the end of this class. I will make the recordings available to the class rep as soon as possible so that for those who do not understand can go over it to get it. Anyway, I don't expect all of you to understand it. Some will understand today, some will understand when they play it back. And the irony is that some will never understand it at all. So that one I know is normal. It's not anything new to me. Okay, so wish you all the best. Enjoy the rest of the day and have a good afternoon. Bye-bye.